Welcome back. This will be day 11 of me learning TypeScript. Yesterday I just finished some type narrowing, which I had finished on level 5 in day 9, and then day 10 I finished that. So today's day 11. We're starting classes. Okay, I'm hoping this will be quick because it's just a class, bro. Like, we've been doing classes, object, whatever, boom, 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 boom. Okay. So that's that. Let's just get into it. Classes in TypeScript work mostly the same way they do in JavaScript. Okay, JavaScript has classes, guys. Shut up. Stop trashing on JavaScript. ES6 does provide classes. Okay. But with the added benefit of static typing, one of the biggest differences is that you'll see type annotation on all the class properties at the top level of class declaration. This is what they're talking about. Okay, so it's the same, just that here they are statically typed. Okay, in JavaScript they'll be dynamically whatever, and then without this type, just say whatever. Okay, so this is a constructor taking in health and name, assigning those. There's the tag, get health. Okay, create an instance, instance of the hero class, and then pass in the required thing, then call the method. Okay, assignment. The managing is as the refactor the user logic to follow an object-oriented structure. Create a customer class. Okay, there is a customer class. Add two strings properties. You create first name and last name. Write a constructor to set the two properties. You do this dot first name equals to first name, whatever. Yeah, I've like this. It's like this current object. I think this current object, and then it's equal to this name. Okay, so that's that. And then complete the girl full name method. It should return the full name by concatenating the user's first name and last name. Just return the first name. Okay, we're not even gonna do that. That's okay. Private class members. Okay, so class members can be public, private, and protected. So now we're talking about private. JavaScript added support for the private class member in ES 2022 with the hash syntax. TypeScript respects that syntax and will give you compilation errors if you try to access private members outside of the class. Okay, yes, it's oh man. So like I've never seen this. I remember like just writing it as private, but this syntax it's like my first time seeing the syntax. Okay, so okay, they try to do some Golang type thing where like capital means private and then whatever. Okay, so hash means this is private, and then we have to use it everywhere. Come on, man, this syntax was bad. Okay, then there's the string method. Okay, because it's inside the class, it can access the ID. I guess, is it accessing it? We don't know. It is there. You access it with this thing, and then we create an instance, call the method, and then you can't do this. Okay, in plain JavaScript would only get an error at runtime, but with the same syntax in TypeScript, we get an error at compilers are much better. Yes. Add a private balance member, so you get a balance member here, include it in the constructor, then you would put balance there. Complete the purchase method. It subtracts the cost from the balance, so it would do with the cost from the balance and returns the new balance with the cost, because like we're giving a private balance property, including into the okay balance there, it's already included, so we just include it here and do balance dot whatever. So here we'll just do okay. So this method already gives you the cost, and then you just minus the cost from the balance that you will have here. Okay, that's that. I mean, that's not even learning TypeScript, that's just a problem they give you to solve. Okay, TypeScript public and private. JavaScript hash private fields didn't come until ES22, but TypeScript developer had wanted public private protected access modifiers for a long time, so TypeScript added support for private and protected before then. So a lot all the TypeScript code uses the keyword syntax to create private members. The TypeScript only way you use the private keyword. Yeah, this is much better. That hash syntax. Get it out of here. Okay, then the constructor will do that. Then this method is inside, so you can use the string. What is this method taking in? So it's a method get name that returns a string. What is it doing? It is this id to code map, and then record, okay, which is just an object. This, I think, it's just saying this will be an object that is the string. So string, I guess, yeah, of string key and string value. Man, this nigga sending me like multiple messages at once. 1 2 3 4 5. It just sent a 61. I'm not gonna respond. I'll respond after I finish making this video. Okay, so we return the object. Okay, this object. Okay, we just access this.id, so we'll access about the id, and then if like the id provided whatever is not one of the two, then we'll return unknown agent. So we create an instance secret agent 007, so it will be James Bond. So if we get code name, this will just return James Bond, and then property id is a private only, so you can't do this. Which syntax should I use? The only reason TypeScript specific syntax exists is because JavaScript didn't have the symbol syntax until year 2022. I recommend using the JavaScript syntax because it's the JavaScript native way of doing it. Remember, TypeScript is basically just tools for writing type safe JavaScript. So conforming to JavaScript standards is the long-term play. I only recommend using the TypeScript specific syntax if you need to target an older version of JavaScript that doesn't support the syntax. This is the only advice this guy is giving so far that I will not take. I am not going to be using the hash symbol. I'm going to just write private here or protected. Come on. Okay, which syntax is preferred for private fields? Okay, so they said this because it's a JS native thing and it's still supported by TypeScript, but no, we will not be using it. Okay, we are not going to use that syntax. Protected data members. Protected, I think it says, okay, it can be accessed by the children of that class, I think. The protected keyword is a unique TypeScript in that it's not part of the ECMAScript standard. Wait, it's not. It's a unique TypeScript. It's unique to TypeScript in that it's not supported by the ECMA standard. Wait, why it's not? It allows you to define members that are accessible within the class and its subclasses, but not from outside the class. Yes. It can be accessed by the class, within the class, and by the subclasses, but it cannot be accessed outside the class. It's like a private, but also accepts. Anyways, sorry. Protected, yeah. Okay, then the constructor, a protected function. Okay, protected functions, whatever. Okay, so yeah, we're doing some inheritance. Even though, okay, we have two fighter, the class fighter is a child of the character, so it can use it has access to help and this function. They're now doing inheritance without telling us that about inheritance. Okay, that's the TypeScript team. No, that's the boot.dev team. Sorry to the TypeScript team. That's the boot.dev team. Okay, not that boot.dev team. That's this guy. I always forget his name. I only know TJ and Prime. Okay, so that's the constructor. So you have to use this super thingy to, if the property is coming from the parent, right? Use this super keyword. Public fight does its own public method, which does this to take damage and then passes in a damage. So this is how you call it. And then console log the instance of fighter passing down health is 100, fighter.fight 30, damage is 30, so console log fighter.health should be 70. What's going on here? And then take damage. Error property take damage is protected. It can only be accessed like this from inside the inside the both classes, but not outside. The product keyword does not have a native JavaScript alternative. I personally don't use it very often. Yeah, I see why. I tend to use private fields whenever possible, or just leave them as public. Yeah, everybody uses public, bro. Unless it's something that you want to protect, then you would use private. Not protected. Okay, man, like I see why you would use protected. Okay, yo, I see why. As I meant, a regular customer is just a more specific type of customer. So let's see. Okay, a regular customer is just a more specific type of customer where their balance needs to be accessible via the getBalance method. Okay, so there's a customer class, and then there's a regular customer. It's just a more specific warawara of customer. Here would use the super to fill in using the constructor anything that is coming from the parent. So it seems like everything is coming from the parent, so we just do super first name, super last name, super balance. I guess like wow, we did yeah, okay, because it's already did this dot warawara in the parent's constructor, and the parent's constructor will be run. I think that's like how we do it. Okay, where their balance need to be accessible via the getBalance method. Okay, what's the getBalance method? Okay, so this need to be protected. Balance is private, so it needs to protect. Complete the regular customer constructor. It should simply call its parent's constructor. Notice that the getBalance method is trying to access private field, fix the error by adding the class to make the balance field protected. How you can just make it public, man. But like, okay, it's a balance. You want to keep somebody's balance protected. So here you just use the protected keyword, and then here you to initialize you use the super, and then there you have solved the quiz, so to speak, in this lesson. Okay, abstract classes and method. Abstract classes and method. Okay, an abstract class is a class that only provides a blueprint. Say a book. When you hear the word book, you have an idea of a book, but you don't know the color, the title, whatever. Okay, so it just gives you like the blueprint of what it is, and then the implementation is onto you. I hope that's what it is here. Okay, an abstract class is a class that cannot be instantiated directly. Yeah, it's you use it to extend from it. They did not talk about inheritance, but we're going to be inheriting. Okay, that's not the book.dev style. Okay, you know this. Okay, we don't go over it. You know this. Okay, they expect you to know. Okay, an abstract class is a class that cannot be instantiated directly. So the reason why I'm going to fast in this course is because like I am familiar with programming concepts. Okay, I'm a second year student. Okay, so I am familiar with programming concepts. So not a lot of things. I'm not gonna like spend time like thinking what is an abstract class. Okay, we know what does this. Okay, it's a template for inheritance, forcing subclasses to implement specific methods or properties. Say you have a shape class. Okay, that's that, and we have a size union, and then the constructor size can come as a so it's that union. Okay, size is okay. Size is of type this. It can be a type of this, and this is coming as a type of this. And then this the size equals the size, and then abstract calculate. Okay, this is an abstract. Okay, an abstract class needs abstract methods, which means they will be implemented in the subclasses, but it can have like methods that are already implemented that the subclasses can just use, I guess. So we can do this shape, the new page. Okay, we cannot do this. You cannot create an instance of an abstract class, and here we use an abstract keyword just like in Java. In C++, I don't think you use an abstract keyword. I forgot. Within an abstract class, abstract methods like actually do not have an implementation because the implementation must be provided by the subclass. However, it can still have regular methods like this way, which are shared by all subclasses. Yes. So you can have like a method like this, which will be shared by the subclasses. However, it can have which will be shared by the subclasses. So we can create a circle class that extends the shape and implements the calculate area method, which returns a number. So class circle acts and shape, and then radius is a number, and then we have a constructor. Super is coming from the parent, so we do this. If size is small, then assign like that, and then implement this function, we return a number. Okay, of course. And of course, the circular class can be instantiated. Yeah, this is just a subclass, so it can be instantiated. So you create that instance and then call the display area, which will return some number. It's a number here. Okay, it's not double. So this isn't your Java or C++ or whatever. It's TS. Okay, it's a number. Okay, number is a number. Yeah. Like protected, the abstract keyword does not exist. Does not exist in native JavaScript. Yeah, like I've noticed, like it's not there. I've read JavaScript, so it's a TypeScript only feature and helps you enforce rules on subclasses at compile time. The abstract, yeah, yeah. This is just to restrict yourself, man. It's just at compile time. At runtime, it's the JavaScript working. It doesn't have it. It's not exist. It won't exist when the at the final compiled JavaScript. Okay, the abstract keyword and keyword and the abstract only methods are removed from the compile code. The abstract keyword and abstract only methods are removed. What? They are removed. So like this will at the end of the day, this will be like this class. This method in this class is just being implemented. So yeah. So this will be removed. This is just you writing TypeScript so that it looks like other languages that are popular like Java. Okay, well, never use a custom object directly in your support AI. Okay, well, we'll never use a customer object directly in your support AI. Just template class for support enforce this behavior compile time. So you do export abstract class, and then that's that. Classes implement interfaces. Yeah. Okay, a class can implement an interface and multiple interfaces actually using comma. Classes implement interfaces. Classes can implement an interface using the implement clause. Okay, did you hear that? This enforces that the class adheres to the structures defined in the interface. Say we have two interfaces. We have the interface vehicle, which is a make model which has strings, interface drivable, which is a method that takes in a distance as a number and returns nothing, absolutely nothing. And we have a class that we want to implement. Okay, interfaces. A class can implement an interface. Yeah. Can an interface implement extends a class? I think interfaces extends each other, and then as we learned in the previous lessons, and we have a class that we want to implement. Have the properties of method. Okay, and we have a class that we want to implement both interfaces. I want to have the properties and methods of implementing is just saving the properties and methods of. Okay, class electric car is making a model which is already there in the vehicle. So class electric car incorrectly implements interface drivable. I'm gonna add a clause to the class definition to implement both interfaces. However, because at the moment the class doesn't have a drive method, types will throw an error. Okay, so like if you implement an interface from a class, all its methods are required that you implement them, and what about the properties? Okay, what about the variables or the properties? Okay, so now we are reminded to add the drive methods, and we do so. Okay, electric car implements vehicle and drivable, and it is make and model. So and you have a private is running, and you have a constructor that does that, and then we have to implement this. So we can use an instance of electric car as a vehicle or drivable. So the constructor is taking in how many things? Two things: the model, the make and the model. But okay, it instantiates is running to false again, which is already false. Man, okay. Tesla.test. Okay, test function to test drive takes in a vehicle, console log, vehicle make, vehicle model, and then test drive and then passing an object, passing an instance. Okay, it's an object though, but yeah, it's an instance. And then there's that instance dot make, which are they accessible? Yeah, they're public. And then the function take for a ride, is it drivable? And then we just did drivable dot drive, it's a method. Then drive dot turn, drivable takes in a number, and then that's true console log driving distance. Okay. So the car is driving for 10 miles. As I meant, let's refactor this code and use interfaces. Run the code as is. Notice that the methods in regular customer class are not running the types the test suite expects. You see the methods in regular customer, okay, it's a class which has 2 public and 1 protected balance, which is being initialized by the constructor. Full name is fine. Okay, so the methods are not returning the types as the type suite expects. So what does the type suite expect? It's returning an object, balance currency, setting a full name. So full name is a method. Okay, so this, okay. Notice that in class we don't use let, var or const. Just write it as is. So get full name and get balance. So like we just need to implement here, right? We just need to implement, and then the code will not have errors because first name, last name, and get full name is there, and then they are all implemented. So they're not returning what? Check out the regular customer implements customer and user interfaces. They should give you some new type inting information to show you what formats the data should be returned in. I mean, I think we just need to implement here what is returned. Like it's just this object. There's nothing wrong with this. What does the type suite expect? So if new customer do this, okay, let's see, create an instance of regular customer John Wick 999. But I think the constructor is taking 3 things, or is taking in a balance too. Okay, the balance is 999, then the expected name will be John Wick, and the expected balance will be that. Okay, so it's returning an object here instead of just a string, I think. And then this expected balance will be just 999, a number. Okay, so yeah. So here this will not want, when you like implement, it will give you an error because like here we are returning an object instead of a string. So we just remove these objects and then remove this, and then that's that. It will work now. And then here it should return a number, so you don't have to return this. You just need to remove this, and the thing is just return this dot balance, so it turns a number because you have implemented this, meaning it should be they should be of type what is already defined in the interface, whatever. Okay, I see. Classes versus interfaces and types. Okay, what is the difference? Okay, this is a class and this is an interface. This is a type. Okay, which one do I love the most? I love types because you can create tagged unions. Interfaces, the guy said like you can do anything you can do with interfaces with types. Classes very important when you want a structure and do some object-oriented programming. You might be wondering, when should you use a full-blown class to create reusable object types over interfaces and type aliases? There are only 3 ways to model the same thing. Okay, if you just want to do this type of thing, creating a type like this, you'd use a type. If you want like a structure, okay, like an instance with methods and stuff, is a class. Like, If you want to keep something like a bank account, there's methods and there's properties. You can use a class. Okay, use a class. Okay, if you are an object-oriented programmer, you might be more comfortable with classes and the extra features they provide. Classes can basically do everything that interfaces can do and more. Some of the most notable things you can do with interfaces and type analysis are have private, property, protected, static, and abstract members. Okay, if dedicated, like I was saying, like if you want to create a bank account, you want something to be protected, whatever, private, whatever. So you would use a class in that case. But if you just want to create types and you have this amazing types, you just use a type. Okay, type alias. You have dedicated constructors, have methods, implementations, predefined or on all instances support inheritance. Okay, you'd use on the other hand, type aliases and interfaces. You have no runtime overhead. Type aliases and interfaces have fewer features, and as a result, they are simpler to work with when you don't need extra features. Type aliases and interfaces are more flexible, especially when working with plain objects, because they are not tied to a class implementation signature only. Type interfaces can be extended and meshed in ways that types and classes got. In interface you can like use the same name and then for two interfaces and then just be merged. Okay, that's personally, I'm a simple man. I intend to use type aliases. Let's go when I can, and only reach for additional features of classes when I feel I need them. Which is rare in web development, at least in my own opinion, because you're going to be using TypeScript for web, whatever. Anyways, which of the following is false? Type aliases are simpler and more flexible. This is true. Interfaces have inheritance. No, you're just extending. That's not inheritance, right? Is it? Maybe it is inheritance. Classes are predefined methods on all instances. You can't like define a class on an instance. This is true. So classes have interfaces have inheritance. I think is the one that's false. That's just extending the thing. Is it inheritance though? That's just extending your interface, man. That's just saying it can have properties that are there, but it's not like you can do like protected and have. Okay, let's see. Classes have predefined methods. Classes predefined methods on all. No. On all instances. I think this is false. I don't know. I one of the two, but I feel like this is false. Interfaces, those are instances. That's inheritance, right? Using the extend to saying this interface can have more. Is it inheritance? It wasn't that bold as inheritance. It was just saying we can extend an interface this way. Okay, that's that. Okay, this keyword, this just says we're referring to this object. Okay, this thing. Likely TypeScript is smart enough to handle defining this keyword for us, because as a JavaScript developer, we know that the only question more difficult than what is the meaning of life is what is the value of this. It's this object. It's like this will be this is simply typed as is implicitly typed as counter. Implicitly typed as counter. So it's like this object of, it should be like this instance dot count this variable plus. Okay, which will be this variable. Then get count will be this dot count. This implicitly type is counter. Explicit this will be implicitly. Explicit these parameters. TypeScript is pretty smart, especially newer versions, and usually infers the type of this correctly. However, if you want to explicitly control the type of this, you can use the special this parameter. Private again if this. Okay, so you just do this. This is TypeScript is smart. This is explicitly typed as counter. This parameter is not available at runtime. It is only used for type checking. Okay, this is explicitly typed as counter. You can do this if where you're gonna use this, but to be inferred as the correct type. So relax. Okay, let TypeScript do the work. Just chill out. Assignment: you need to Add some code to keep track of the number of time a regular customer checks their balance. This is me every day checking my balance, thinking it will increase. Man, nigga broke. Add a private balance. Add a private balance queries property. There's a number with the class. Yeah, you just add balance queries as type number. Each time get balance is called, increment the count. What's the get balance method? It's the get balance. Then you would increment the count. What's the count? Increment the count. There's no count here. Private, okay, add a getter for the new private field. Okay, this is private. It needs a getter to be able to balance queries to inside the same class because it's private, so you can access it and return the field. It's a getter, not a setter. It's a getter. Getting it? Okay, so each time get balance is called, you increment return. Okay, get balance is called. Each time get balance is called, increment the count, so it will be plus plus distant balance. Okay, then the get balance queries just calls this. Get balance queries just returns this balance queries. But where is it like balance queries like managed? Okay, let me now maybe it's time to code. Like I didn't code in this section. I thought I was eating. Okay. So we need should we use the hash as advised and do balance queries? I think they say it's of type number. See, it's not even working. How do they do this? Yeah, let's just use the private man. Like I already forgot. This field is declared but never. Oh, we're getting the error. It's declared but never used. Okay, it was correct. I think it will be returned here. Return balance. Okay, yeah, it will do that fast. So each time this is called, we need to increment what? Okay, there's still an error. Balance queries. What? Yeah, this is not initialized, or it's not assigned in the constructor. So where is it assigned? Is it the one we are? Is it the count? Is it the count that we are incrementing? I think it's the count we're incrementing. Okay, like well, let's see. Each time we get balance is called increment the count. Where's the count? The count, the balance queries. Yeah, it seems like we're adding code here, so we'll do, and we can't just do it like this. It needs to be assigned first. So let's just do it's just this syntax. This syntax just adds one. It won't work. Okay. Oh, it's not used, man. Like what's going on? Let's just do balance queries that, of course, if like it's not called, then there'd be 0, right? Queries 1, expected 1. The test case is what are we passing to our, it takes in 3 things, I think. The first name and balance, and then queries is 1, then it will expect 1. So which method will be called? I think it will be get balance queries, the method that will be called. let's see, yeah, it is the get balance queries method that will be called, and then we are incrementing by 1 each time get balance is called. So let's need to create a new instance of type regular customer and pass in some stuff there. To pass in John week 999 or hashtag. How much should I have in my account? Yeah, we rage. Wipe that. Okay, so we created that instance. Yeah, it's taking in 3 things right in the constructor. Blah, 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 blah. Yeah, so we created that. So we can console log the object dot what's that get balance queries method that doesn't take in anything, so we should get 1 from this, right? 0. Okay, because the customer didn't get the balance, they didn't try to access the balance, so would need to console dot log get balance. Where's the get balance method? How is it written? Okay, object first dot get balance, and then do that. The customer gets their 0 balance first, and then yeah, and then we can say that they'll try to check for their balance once. Okay, that will be that for today. How long is the video? 36 minutes. That's a long time. Okay, so thank you for watching, and I will see you guys on day 12.